Question number 5. During 1 year, 1.25 times 10 to the power of 18 joules of energy was transferred from the national grid. Number of seconds in 1 year is given to us as this is the value of time, and this is the amount of energy that was delivered in 1 year. It says calculate the mean energy transferred from the national grid each second. Now this statement also means basically they're asking you about the power, because power is defined as energy per unit time. Okay, so this is the amount of energy that will get delivered in 1 second, and that's what we call power. So instead of using word power, they are defining the same thing but in another way. So they're saying calculate the mean energy transferred from the national grid each second. Each second means I'll have to divide this value by this time, and that would be 1.25 times 10 to the power of 18 divided by 3.16 times 10 to the power of 7. Now I do recommend before you plug in these values in your calculator, you put brackets around it. Once you've done that, and if you plug it in your calculator, you'll end up with a value of 3.96 times 10 to the power of 10. Now I have to be a bit more careful here, because it says give your answer to 3 significant figures, and this is my 3 significant figures. Next part says figure 5 shows a house with a solar power system. The solar cells generate electricity. When the electricity generated by the solar cells is not needed, the energy is stored in a large battery. So here's the house, there are the solar cells, and you've got the large battery, but energy will only get stored in this when energy is not needed by the house. Remind yourself that solar cells have low efficiency. Number 1. Number 2, they can't generate electricity at all times. Can't generate electricity at all times. So you will need the presence of sunlight for them to work, otherwise they will not work. The question says the charge flow through the cable between the solar cells and the battery in 24 hours was 2700 coulombs. So this is the value of time, and this is the value of charge, which is represented by letter Q. It says calculate the mean current in the cable. I do not know the value of current, which is represented by letter I. Now I need to pick up equation that links these 3 variables. The equation is Q is equal to I times T. Now remind yourself, in this equation, Q has a unit of coulombs, I has a unit of amps, and T has a unit of seconds. So you will need conversion of these hours into seconds. How do you do that? We'll just do 24 times by 60. This will convert it into minutes, and then you multiply it once more by 60 to convert this time into seconds. Now this is in seconds. Once I've done this conversion, the next bit I need to do is I just need to plug these values in the equation and solve, and I will end up with the answer. So here the value of Q is given to us as 27,000 equals, we do not know the value of I, I'll keep it as I, but the time has a value of 24 times 60 times 60. Now I will rewrite it, but this time I'm going to multiply them numbers together and replace this by a value. So it will be 24 times 60 times 60 gives me 86400. Now to get it off this 86400 from the right side, I'll divide both sides by 86400. 86400. This is gone, and I'm left with I only on the right side, and on the left side, if you divide them 2 numbers, you'll end up with 0.3125 amps. Next part says at one time the total power input to the solar cells was 7.8 kilowatts. So it's power input, P input. The efficiency of the solar cells was 0.15. So this is the value of efficiency. It says calculate the useful power, so we do not know the value of useful. There's an equation that links these 3 variables, that is efficiency is equal to useful over input. In this case, if you use input as 7.8 kilowatts, then the value of useful that you will calculate will also be in kilowatts. Let's keep it that way. So I can say efficiency has a value of 0.15 equals useful. We do not know. I can keep it as useful. I do know the value of input, which is 7.8. Now to make my life easier, I can put 1 in the denominator on the left side. I've got single fraction on both sides. I can then multiply cross. I can then cross multiply and solve. So this will give me useful will be equal to 0.15 times 7.8, and if you solve it you will end up with 1.17, but remember it will be in kW, kilowatts. Now the question says you have to give your answer in watts. So what will you do? We'll have to multiply it by 1000. So the answer will be 1.17 times by 1000, and this gives me 1170 watts. Last part of this question, it says it is unlikely that all of the electricity that the UK needs can be generated by solar power systems. All of the electricity. Explain why. Now, we've discussed a few limitations at the start of this question on the last page. So remind yourself they have low efficiency. Number 2, they require sunlight. UK has fewer sunny days per year, and that should be sufficient for this.